Hey guys, Mrs. O'Donnell here. This week we are starting on polynomials. Our goals for today are to classify polynomials, to learn some polynomial vocabulary, and to write polynomials in standard form. I posted an agenda for you. I will continue to update this agenda throughout the week, so you can go right back to it and check it out if and when you need to. If you miss a day for the Google form, just go back, try and get it done. I would encourage you to try and do each assignment the day that it is assigned, but obviously I understand when things come up. So just keep an eye on your gradebook and email me when you have questions. All right, so our introduction to polynomials. So polynomial comes from the first part, poly, meaning many, and the second part, nomial, meaning term. So it literally means many terms. A polynomial consists of constants, variables, and exponents. The constant would be just the number, just a single number, right? So for example, in this binomial, the constant term would be the 7, okay? It also consists of variables like x and y, so you'll notice each of these polynomials shown here have variables, and there are exponents. So for example, this squared value on our x squared would be an example of the exponent. The number out in front of your variable is called your coefficient. So polynomials consist of these terms that can be combined using addition, subtraction, multiplication, and division, except you can't have division by a variable. Okay, so let's look at what that means. So is it a polynomial or not? So we know, hey, we've got this leading term, leading coefficient, highest degree or power, and we'll talk more about that in a little bit. We've got sort of a middle x term, and then we've got our constant term. We want to remember that our exponents can only be whole numbers. They cannot be fractions. We can't have fractional exponents, which if we think back to our exponents unit, we know a fractional exponent can also be represented as a radical or a root. And then we also want to remember that we can't have any variables in the denominator. And again, if we flash back to that exponents unit, a variable in the denominator, if you pull it up out of the denominator, that exponent would be represented as a negative. So we can't have variables in the denominator or negative exponents. All right, so if we're checking out down here, we want to sort of categorize. Is it a polynomial or not? Take a minute right now. You can pause the video and challenge yourself. Is this a polynomial or is this not a polynomial? And each one of these is an individual problem. Okay, so now you've probably unpaused the video, so let's check out the answers. So first of all, we cannot have fractions in our exponents. We know that first one is not a polynomial. We also can't have a radical, we can have a radical 3. We could not have a radical x. So that is an example of a polynomial. Here we've got a negative exponent on our variable, so that is not a polynomial. Here we have a radical sign on our x, so that is not a polynomial. Negative 3x squared is a polynomial, and this last one is not a polynomial because you cannot have your variable in the denominator. All right, so hopefully that helps you have a little bit of a better grasp on your polynomials. All right, so again, a couple more examples, so try it again. Pause the video, take a couple minutes, determine whether the expression given is a polynomial or not, and try to think why, if it's not a polynomial, why? All right, so if you're just coming back from having paused the video, let's check out our answers together. So this first expression, A, is not a polynomial because of that square root over top of our x. Okay, B B is a polynomial. 2x cubed minus x squared minus 5 is absolutely a polynomial. C is not a polynomial because of that negative exponent on our variable. And D, that one is a polynomial, right? 2/3 x cubed minus x to the power of 0. So what makes polynomials so special? Well, because of the strict definition, polynomials are really easy for us to work with. Okay, so for example, if you add polynomials, you'll always get another polynomial. If you multiply polynomials, you'll get another polynomial. Polynomials are really nice and easy to graph, and we know that we learn a lot from looking at the graphs of our different functions. But if you divide polynomials, you may not necessarily get another polynomial. So that's the only one you want to keep in mind. Dividing polynomials, you may not necessarily get another polynomial. So next we want to think about how to classify polynomials by their degree. The degree of a polynomial with only one variable is the largest exponent of that variable. Okay, so for example, a constant doesn't have a variable, right? A constant would just be a number, like the number 7 or the number 15. Those would be examples of constants, or the number -200, right? Those are all examples of constants. The degree technically is 0. I could rewrite 7 as 7x to the power of 0 because I know anything raised to the power of 0 is actually just 1. So that's really 7 times 1, which we know is just 7. Okay, next we have linear equations, okay, or first degree polynomials, right? So for example, 7x would be a first degree polynomial, or 3x minus 2 would be a first degree polynomial, or 5 times x plus 1 would be a first degree polynomial. Okay, that highest power on each of those is a power of 1. Quadratics are a second degree polynomial. Okay, so our quadratics, an example of a quadratic would be like 3x squared, or another example of a quadratic would be like -7x squared plus 0x plus 2. That would be an example of a quadratic. Okay, and then let's see what else. Or like 1/2 x squared minus x. That would be an example of a quadratic polynomial. You want to keep in mind that we don't have like terms here, so we cannot combine our 1/2 x squared and our x to the first power, right? In order to combine like terms, your powers have to match exactly. Next, we have a cubic. The degree on a cubic is a 3. Okay, so for example, 27x cubed would be an example of a cubic, or 8x cubed minus 7x squared plus 5x minus 2/3. That would be another example of a cubic. Let's see here. Next, we have a quartic. Quartic has a highest degree of 4. Oftentimes, after cubic, we just start calling it by the number of polynomial. So this is often referred to as a 4th degree polynomial as well. So for example, -2/3 times x to the power of 4 would be an example of a quartic. Or 6x to the 4th minus 2x cubed plus 11 would be an example of a quartic. A quintic is a 5th degree polynomial. So an example of a quintic would be like 9x to the 5th power. Or another example would be like negative 2x to the 5th minus 5x cubed plus 2. Okay, an nth degree polynomial has a highest degree of n. So you can basically keep going. You can have any degree polynomial that you want. You could have a 100th degree polynomial. You could have a 1,000,000th degree polynomial. So this is basically just anything raised to the nth power, okay, plus 2x to the n minus 1 plus 3x to the n minus 2, and so on. Okay. Knowing why, you might be asking, why does it matter? Why do we need to know the degree of the polynomial? Well, knowing the degree of a polynomial function will tell you the most number of times the function will cross the x-axis, which we often refer to as the solutions to the polynomial. We can also classify a polynomial by the number of terms in that polynomial. So, for example, let's see here, this first linear example that I gave, the 7x, that's just a single term all by itself. So that would be an example of a monomial. It just has one term, kind of like a monocycle, right? Or this very next example, right, I have 3x minus 2. Its terms are always separated by addition and subtraction. So I actually have two terms here. That would be called a binomial, having two terms. Think about a bicycle, has two wheels. Let's see here. Down here, let's see, 6x to the 4th minus 2x cubed plus 11. Here we see three terms, right, separated by subtraction and addition. So we would call that a trinomial, right? So this would be a quartic trinomial right here, okay? Or down right below it, you see a quintic trinomial, okay? And so on and so forth. So the last thing that we're going to talk about today is how to put your polynomial into standard form. So standard form for writing a polynomial is when all of your like terms are combined and your degrees of each monomial are arranged in descending order. Okay, so what we have to use to be able to rearrange our polynomial is that commutative property of addition. So I have to go through and make sure that I have addition between all of my monomials. So I see a red flag right here. I have this subtraction sign. So I'm going to turn that into adding a negative 8. And now that I have all addition between my terms, I can go ahead and rearrange them to put them into exponents that are in descending order. So my highest exponent is a 5. So I'm going to rewrite this as 3x to the 5th power. Then I need to write a term to the 4th power. Okay, so in descending order means that I'm going to start with an exponent of 5. And I'm basically just counting down 5, 4, 3, 2, 1, 0, or none. Right? So I don't see a 4th power in my current polynomial. So what I'm going to do is I'm going to fill in a 0x to the 4th. Okay, so it's kind of my space keeper. And then I've got my 4x cubed. Then again, I don't see an exponent of 2, so I'm going to fill in 0x squared. Then I've got 2x to the 1st and negative 8. You could write your x to the 0 there, but we know x to the 0 is just 1. So that would be how you'd rewrite that polynomial in standard form. All right, that's all I've got for you guys today. So you should be all set to finish up your Delta Math and then complete your Google form. Don't forget to come to my office hours with questions. I've got 2 office hours, one from 7:30 to 8:30 a.m.